Thank you so much, Arthur, and thank you so much, Your Holiness, and thank you to all at the Drepung Monastery for making this a very, very special and momentous occasion for us. For those who are visiting, it's been really something very different than any other Mind and Life meeting, and I think we all feel it in our hearts and understand at least a little bit, I think, how important this meeting is for Your Holiness and for the monastic community. And I think, speaking on behalf of all of us, I think we all feel a real gratitude to play a small part in the curriculum change that this event is really celebrating. Today, Your Holiness, I will begin to talk about neuroscience and also contemplative practice. On the very first day of the meeting, I said a few words and talked a little bit about the complexity of the brain and how it's probably the most complex piece of matter in the universe. After sitting through yesterday, I'm deeply humbled by my physics colleagues, and I think that neuroscience now is a much easier task than after knowing what my physics colleagues have to struggle with. So we'll see at the end of today what the collective judgment is.
More complicated because the brain specialist in any way is dealing with mysterious subject, just consciousness. You cannot measurement. More mysterious, more difficult. Your task is more complicated.
So, Your Holiness, today I will first talk about two major systems in the mind, if you will, or two major constructs. One is emotion, and the other is attention. And I talk about these because from the perspective of Western science, there seems to be consensus that contemplative practice affects these processes. That is, it affects our emotions, it affects our afflictive emotions, it affects our positive emotions, and it also affects our attention. And so, from a Western scientific perspective, it makes sense to us to begin this project by focusing on these constructs which we think are relevant to the impact of mind training. And so I'll begin by asking, what are the key neural circuits that underlie emotion and attention? And then we will consider the idea that these circuits are plastic, meaning that they can be transformed by experience, and therefore they seem to be relevant for the opportunity to be transformed by contemplative practice. And then finally, I'll talk about the impact of different kinds of contemplative training on both emotion and attention, and I'll give one or two examples. And so that's the plan for this talk. I want to begin with an important figure in psychology and neuroscience from the West that has already been mentioned at this meeting, and this is William James. And in addition to his insights about attention, which we've heard a little bit about and to which we will return later this morning, William James also had some brilliant ideas about the nature of emotion. And I'd like to share the William James's understanding concerning the nature of emotion, and that is depicted in this diagram to the right. And I'll walk through this diagram. If you look at the right-hand side of the diagram, it says sensory receptor. Those are the sense organs, the eyes, the ears. And William James's notion is that sensory information comes into the brain through the sense organs, through the eyes, through the ears, and so forth. And it goes up to the cortex through some relays, which we'll talk a little bit about later, but eventually it reaches the cortex, the highest level of the brain. And then from the cortex, if you look at the arrow that is denoted number 2, there is a line going from the cortex down to the viscera, which are our visceral organs like the heart, the lungs, and so forth. And so there are projections, there are connections. This is William James' view, but this part of it is clearly confirmed by modern science. So we know that there are pathways from the cortex that go to the heart, that go to the lung, that go to the different visceral organs. That is known, and that's not controversial. So,
His Holiness is asking, are you suggesting that these visceral organs play a role in perceptual processes?
They play a role. They play a role in emotional processes. So the idea is that the brain is perceiving the senses, and then once the senses are processed, the information goes from the cortex down to the visceral organs and also to the skeletal muscles, to the muscles in our face, the muscles in our body. And then just to continue, the arrows that are denoted number 3 project back up to the brain from the visceral organs, from the heart and the lung, as well as from the skeletal muscles. They project back up to the brain. So for William James, what he argues about emotion is that when, for example, if we see a tiger in front of us, the sensory information goes up to the cortex. The cortex sends signals down to the heart, down to the lungs, down to the muscles, and we experience our heart beating more quickly, we flee, and then he says we experience fear only after those changes occur in our body. And so for William James, the changes first occur in the body, and then the signals from the body go back up to the brain and inform the brain about the state of the body. And then once the brain detects that the body is agitated, then the experience of fear arises. So in a very famous passage in William James's book, The Principles of Psychology, he says, we see the bear, we run, and then we are afraid. So this is a view which has had a very deep influence.
No.
So one occasion, some scientists used to told, fear develop, then the muscle goes leg, the blood
goes
more.
into them.
So obviously, anger comes, then blood circulation go hand, ready to boxing. So that means, you see, the physical sort of change, this blood sort of, also the because of the rushing. That's naturally related to the heart. and some other sort of body element. But trigger of that is here, feeling, fear.
The fear.
So I thought, if fear come first, then physical reaction come later. So you just opposite.
That's right. So this is William James's view. So which is right? So how can we test this scientifically? So I will provide one example of how this can be very rigorously tested to provide an actual empirical answer to that question, which comes first? Is there a way to tell? So in the West, Your Holiness, it's a little bit strange, but there are people who go to their doctors to receive injections in their face to make their face look younger. They receive injections of a molecule that is called Botox, in short. And what Botox does is it paralyzes the muscle for some period of time, and it eliminates the wrinkles. And some people voluntarily go to their physician and get an injection of Botox to make themselves look younger. So we actually did an experiment.
So someone said that, so was saying that if you go too extreme one day, you might not even be able to close your eyes.
That's true.
blink, sorry.
Yeah, to blink.
It's true. It's true. So we did an experiment. This is published in the scientific literature where we decided we can take advantage if people are voluntarily doing this anyway.
That's right.
What we did is we tested people before and then after they received a Botox injection to the muscle, one of the key muscles in making certain kinds of facial expressions, the corrugator muscle, which contracts during sadness, for example, very important. And we then were able to test the same person before and then after we eliminate the skeletal muscle contribution that goes back up to the brain. And so this is an important way to test William James's theory because we're not changing the brain directly. All that's changing is the signals that would arise from the muscles that then go back to the brain. So we can, at least for the skeletal muscles in some key regions, we can eliminate that feedback that goes back to the brain, and we can ask the question, does that change a person's emotional response? And the answer is, it does. It has some effect. And so that experiment, as well as several other experiments like that, suggest that at least to some extent, William James was correct. Where he was not correct is in thinking that all of it is due to the feedback. So it goes in both directions.
Now safe though.
So another important figure in the history of research on emotion is this scientist named James Pepys, it's pronounced, Pepys. And he was the first to actually describe a circuit in the brain that is important for emotion. Not just one location, but the interaction among a group of structures in the brain. He was the first to describe that. And his description is in this figure, and it includes a number of different parts of the brain, such as the hippocampus, which I'll talk a little bit more about in a few minutes, another part of the brain called the cingulate. But all of the key parts of his circuit are enclosed in the dotted square. And notice that the neocortex, the highest part of the brain, is outside of that area. It's not part of the circuit that Pepys described was important for emotion. Now, this is very important in the history of neuroscientific research on emotion because it was suggesting that emotion is processed in parts of the brain that do not involve the cortex. And this was the classical view of emotion for many, many years. And then one of the things that changed that view, one of the most important things, were studies that were conducted primarily from individuals from World War II who suffered damage to their brain in the war. And one of the things that was found is that patients who had damage to the frontal lobe of the brain exhibited abnormalities in their emotion. That is, they showed certain kinds of emotional disturbances. And those were some of the first insights that suggested to scientists that in addition to the parts of the brain that Papes and others have described that lie below the cortex, that the cortex itself, at least certain parts of the cortex, particularly the frontal cortex, may play some role in emotion. And so what might that role be? And that has been the focus of a lot of basic research that we have conducted in our lab, but also many other scientists. And the modern understanding suggests that the capacity to regulate our emotions is importantly associated with the frontal cortex. And one of the things that may be different in humans than it is in any other species is our capacity to regulate our emotions. No other species can voluntarily regulate their emotions in the same way that humans can regulate their emotions. And we think that that probably has a lot to do with the growth of the prefrontal cortex over the course of evolution.
His Holiness is wondering, are you suggesting that other animals are not capable to the degree to which we can exercise regulation?
But otherwise, we can notice. We notice some dogs, some birds. Although they are, I think, physical level, they want something. But mental level, they fear, they sort of little suspicion.
So His Holiness is suggesting there seems to be some ability to regulate. They don't, just keep a check on their instinct.
In that case, with the bird, if they want something, but they have some suspicion or wariness, the suspicion is likely caused by something in their environment that's right there, that's present immediately in their environment. So it may be some...
that is true. That's true.
Whereas in humans...
But still, you see, there's sort of differences. Yeah. The physical level, biological factor, is you want something, you're hungry, want to eat. But another sort of level, mind, warning, be careful. In an animal also, you have that capacity, isn't it? So it's two levels to what?
So to a degree, they do have an ability to sort of put a check, control over their instinct.
To a degree, although that control is in the immediate environment. It's not something that they can call upon purely mentally. It has to be present in their immediate environment.
He's not sure if that is necessarily true.
Also, a certain memory, not like human memory, 10, 20 years sort of memory, no. But I think at least a few months, if a bird or cat or some other mammal, so once they had some kind of difficult experience, then at least memory remain another, I think, a few weeks, a few months.
Yes. It is a matter of...
Yes,
it is a matter of degree. It's not absolute. It's a matter of
There's no question, yes.
Yeah. And there's a very famous set of experiments that's been done in children where if you have a treat that a child wants, something a delicious candy that they really like, and you put it right in front of them, and you tell them they can take that candy right now, but if they wait 5 minutes until the experimenter comes back, they can have 3 candies.
Yes, yes.
And this is a very famous experiment, and some children have the capacity to exert self-discipline.
Age. Can you say the age of those children?
Pardon?
The age.
The age of these children is about age 5 or 6 years of age. And one of the things that's striking about this is the variation across children in their capacity to do this. Some children are able to exert discipline very, very well, and other kids will look at the treat and then just grab it. And it turns out that if nothing else major changes in their environment, when they grow up and they're age 30 years of age, the children who were better at exerting discipline when they were young end up with much better outcomes. They have better ability to regulate their behavior in all kinds of ways. They are financially more successful. They're less likely to get into trouble with drugs. They have all kinds of more positive outcomes as adults. And so this actually is a very important insight because it suggests to us that if we can teach children to exert self-discipline in this way, in a more effective way, then we can actually benefit outcomes later on in life. And this is something that requires the prefrontal cortex. This is a skill which is clearly mediated by the prefrontal cortex.
So His Holiness is wondering whether the experiment has done, I mean here it's an incentive. So the children has been exposed to this candy and has been promised 3 candies if he can wait for 5 minutes. So there is an incentive. So the children knows that he's going to get more. So there is a sort of a anticipation and a joy.
So actually, a certain kind of motivation of positive thinking. So I wait 5 minutes, I gain better sort of
results.
result.
There is an anticipation, something that the child likes. But how about if we do the other way around, where the child is given a candy in front of them, and you just give them a warning that you should not eat it. You should wait for 5 minutes, and maybe even suggest some punitive consequences.
If not listen, some kind of threat. So out of fear, wait 5 minutes. Another one, wait 5 minutes out of volunteer, seeing some positive, seeing some benefit.
The benefits, no?
Yeah, so
So you mentioned that those is a child more disciplined, whole life becoming more successful.
yes.
So some kind of discipline out of fear.
Can it work
Not that kind of positive effect.
Yeah, that's a very good point, Your Holiness, and those experiments have not been systematically done to compare a motivation out of fear versus one out of a joyful anticipation, but there are other experiments that suggest that positive motivation will lead to more enduring and sustaining of behavior change than punishment. So I think that that intuition certainly is borne out by some other scientific evidence. So this is just another diagram of what some scientists have talked about as the limbic system, which is the system important for emotion which interacts with the prefrontal cortex. And one of the areas in the limbic system is this area here, which we've talked about before, called the amygdala, which I'll say more about in a few moments. But the idea that I want to emphasize here is that emotion, just like any other type of complex behavior, is not localized to any single place in the brain. It is distributed throughout a circuit where there are different structures that interact, and the activity of those structures interacting, according to modern neuroscientific view, is what is necessary for the emotion to arise. So it's not that it's located in any one area. There is no single place in the brain that we can say that's where emotion resides.
So not specifically in relation to this particular diagram, His Holiness is asking a general question about the brain mapping and the anatomy of the brain.
Oh, this kind of map.
Yeah.
So what age? I'm wondering this kind of sort of complete sort of form of brain
Emerges.
After say,
Conception.
conception.
In the fetal developmental stages.
6 months, 8 months.
Within the fetal development.
Yes.
It's in the last trimester, so in the final 3 months of gestation, major structures of the brain are formed. But and so all of these structures are present at birth, but they undergo postnatal development. So there's a lot of change physically which occurs in these structures up until at least age 25 years.
That's right, that's right.
So there's
세상
huge-
once Livingston after birth, mother's physical touch
Yeah.
is the one major factor for enlarging brain.
Brain now.
So which side of brain?
Well, again, the warmth of a mother probably affects many different areas of the brain, not just one, and it clearly influences the development of areas in the limbic system as well as areas in the cortex that play a very important role in emotion and emotion regulation. We know the evidence for that is extremely compelling. We know, for example, Your Holiness, that the unfortunate cases of human children who have been maltreated, and we've done some of that research ourselves, you see that the actual size of the frontal cortex is diminished in those children. So being subjected to either emotional abuse or physical abuse actually leads to contraction, to shrinkage of these areas. We've also done studies of children who have been raised in orphanages in Eastern Europe, primarily Romania, where they have suffered emotional deprivation, and they've been then adopted into middle-class families in America. And the age at which we test them is at about 12 years of age, roughly. And they've been in the orphanage for different lengths of time, but at least for 6 months and up to about 5 years. But then they've had at least 5 years living in a middle-class family in America, and what we see is that their brains are still very different when we test them.
So
that suggests that the restoration and revival doesn't take easily.
It does not take easily. That is absolutely true. It is very true, and one of the questions is how best to help those children to restore or to take over, have other parts of the brain take over functions that are impaired by the parts of the brain that are contracted. It's a very difficult problem.
Middle class
So it's just an aside question, nothing to do with your presentation. His Holiness just, thought this question, since you talked about middle-class families adopting, what about millionaires? They don't adopt?
Very rare. Seems very rare.
Is it rare that they adopt?
I'm not sure. Does anyone know the answer to that question?
I think suppose the millionaire, so much money, they can adopt. 그래서
The book adopt chebaliya ningji the keje.
재산가. So I'm just curious. You see, you specifically mentioned middle class.
Yeah. And it's in our data that we've looked at when we have advertised in newspapers for families.
Yes, I just wanted to tease you.
Even scientists, to millionaire, very polite. So not carry test experiment.
Solon is suggesting that the scientists are being more deferential towards the rich so that they don't subject them to experiments.
We test all comers. But, when we advertise, Your Holiness, in newspapers, these families really want to participate in research because they have a lot of difficulty with their children. And they're searching for answers. So they have a motivation to participate. And we have many more people volunteering, many more families than we can. But the families that respond to our advertisements are all middle-class families. They're not from the very, very wealthy. So let me move on a little bit now. I'll skip this slide in the interest of time and just show that I want to introduce the topic of neuroplasticity just to say that neuroplasticity is not necessarily good or bad. It is neutral, and it depends upon what input we have. If we fill our minds with wholesome thoughts and warm-hearted emotions, then we can harness neuroplasticity for the good. But if we're exposed to adversity and to a lot of negative influences, that can have a deleterious, a negative effect on the brain.
So His Holiness was saying that he heard that as a result of exposure to a positive mental environment, such as the experience of compassion and love and so on, in fact give rise to a strengthening of neural connections as well as maybe even birth of new neurons. So does the same effect can be seen in the negative exposure as well?
It can, although the effect tends to be in opposite directions. So this is one example.
Emotion positive.
So given that there seems to be a suggestion that at the brain level itself, at the neural level, there seems to be preference towards more constructive mental, like emotions and so on, and there seems to be
Although I would say the preference is early in life.
So His Holiness's question is, does that mean that even by looking at the brain...
Well, you mentioned some positive sort of because of the emotional feeling, some positive impact.
Yes. Yes.
So constant fear, anger, this negative emotion, negative or
damaging effect,
some kind of emotion are more negative.
Negative, destructive, damaging.
So that means the physical sort of particle, the small particle itself, you see, have some kind of ability, distinction. What kind of emotion? Can
you say that? On the part of the neurons?
Yes, there are neurons which will, individual neurons. Christoph the other day mentioned neurons that respond to very familiar people. There are neurons in the brain that will fire only in response to positive input and other neurons that respond to negative. So there are neurons that make that distinction clearly. And there are circuits in the brain that are primarily dedicated to positive emotions and others more concerned with negative emotions. So there clearly are those distinctions that are made in the brain, absolutely. So, and this is an example, Your Holiness, from research of Bruce McEwen. You met Bruce McEwen at Rockefeller University. He's a very, very eminent neuroscientist. And he has done some of the most important basic research. These are individual cells. And on the left, we have cells from a control animal and then an animal that has been under chronic stress. And what you can see is that the extent of these processes from the cell, these are the dendrites, they actually are fewer in number when the animal is highly stressed. And these are cells from the prefrontal cortex as well as the hippocampus. Those are areas of the brain where stress leads to a contraction, a diminished size, if you will. And the interesting thing is if you look on the right-hand side, those are cells taken from the amygdala, as well as another part of the prefrontal cortex, which we'll not talk about now, but let's focus on the amygdala. And you see the top is from a control and the bottom is from an animal that has been stressed. And what you can see there is that the branching is greater. And so the amygdala is an area of the brain that is particularly responsive to threat and to negative.
So how do you define control in this particular context?
Control?
Yeah.
Control.
Yeah. Control
It's in this particular context, it's an animal that has been just raised in a normal way and is getting fed properly, getting nourished, healthy.
And the stressed one is induced.
The stress is induced.
Right.
Yeah, and the way the stress is induced is by putting a predator near the animal to make the animal anxious.
그래서 멘탈리티 더 숙체로도 more active.
So it seems that in
alert something alert.
Exactly. Vigilant.
Vigilance.
Yeah. So I've described some about the circuits important for emotion. I'd like to now move on and talk a little bit about networks that are important, networks in the brain that are important for attention. And just as for emotion, we think of different aspects of emotion. We've talked about wholesome and unwholesome emotions. We've also talked about the capacity to regulate emotions. When scientists begin to work in an area, they begin to make distinctions. It's kind of like the Abhidharma with lists of mental factors. And so here it's much cruder, but some distinctions. And with attention in the same way, attention is not just one thing, but there are different attributes of attention. And what I'll show is that scientists have studied some of those attributes, and some of them can be distinguished in terms of which parts of the brain are most important for those attributes. So there are three types of attention that are denoted in this diagram. One is called alerting, a second is called orienting, and a third is called executive control. And I'll explain each of these. Alerting is if all of a sudden now there was a big loud noise, which like happened to us yesterday. Some people would turn their attention to the noise. That is what we mean by alerting. So something happens in the environment and our attention is pulled to that. We think of that as attention which is stimulus driven, and we say stimulus driven because the external stimulus pulls our attention toward it. So that's one kind of attention. The second kind of attention is orienting. if I were to tell you...
오리엔트는 초.
Yes. Can you explain?
Orienting.
Yeah, orienting.
Yeah. So for orienting, if I were to tell you that in just a second or two, I'm going to flash a stimulus just to the right of your eyes, and you know exactly where it's going to be occurring, and don't move your eyes, keep your eyes focused ahead, but very, very soon I'm going to show a stimulus there. The orienting is the capacity to direct your attention, not mentally, not with the eyes,
Right.
but just
That's
mentally
right. That's right.
to that location. And you can do that with any sense. So we can be sitting here now and directing our attention to our right foot and the sensations there. That would be an example of orienting. Executive control is where we resist distraction and direct our mind to focus on one thing and inhibit the distracting influences that come from somewhere else. So, for example, if we were standing in a room with many, many people and engaged in an interaction, and if I heard my name being called, I would have a natural tendency to orient or to show an alerting response to my name being called. But if I focus my attention and remain in that conversation, that is executive control, being able to inhibit the distracting influence of the other sounds and keep the mind focused on what it is directed toward. Now, one of the fascinating things is that these are different parts of the brain that are...
His Holiness is Richie trying to correlate that with the Abhidhamma taxonomy and trying to understand in functional terms.
전배벽에 내버려 쳐로. 그 내버려 쳐로데 전부 자이나.
Yes. The nebe. Yes.
that
Because in Abhidhamma taxonomy we speak of mental factors in specific functional terms. So there is a mental factor which is often translated as attention, manaskara, and this is the factor that selects what you're going to focus on. Then there is a mental factor that is the ability to stay single-pointed. And then there is a mental factor whose function is to, in some sense, like executive control, so that you don't get distracted by some other stimulus. You maintain that focus.
So one of the things that's interesting from a neuroscientific perspective is that there are parts of the brain that are involved in these different attention functions that overlap with emotion. And that is not surprising because when we ask ourselves what information in our environment tends to capture our attention, it tends to be emotional information. For example, we show alerting responses to stimuli in our environment which are emotional. We don't show those responses to stimuli that are very neutral. And so it's not surprising that there is some overlap in the brain regions which are important for emotion and attention.
So these are the two sides of the brain, yeah?
No,
Same
sorry.
brain.
This is the outer surface
yes.
of the brain, and the
Interesting.
diagram on the right,
yes,
is
that's right.
inside.
Center,
Yes,
yes.
it's cut in the middle.
Right.
Yeah. Now, in the interest of time, I'll just give one example, and then this afternoon we'll have more time. So I'll give one example of how we can study the impact of contemplative training on networks important for attention, and this afternoon I'll talk more about emotion. So This is the quote that Arthur put up the first day from William James about how the education of attention is so important. And William James said, his last line here, it's easier to define this ideal than to give practical directions for bringing it about. I think if William James had contact with the Buddhist tradition, he would have seen immediately that the methods that are so rich in your tradition, Your Holiness, represent strategies for educating attention. So, this is a little hard to see, but children who have attention deficit disorder, which about 15% of children in the West between the ages of 7 years old and 16 years old are said to be diagnosed with attention deficit hyperactivity disorder. And many of those children are being given drugs to somehow help with this. We think that there may be other strategies for doing it. One of the things that kids with this disorder show is that they're very variable in how they pay attention. Sometimes they can pay attention, other times they're distracted. And so they're just very variable. And what this simply shows, it's a technical way of demonstrating that their attention is very, very variable. So we ask the question whether 3 months of vipassana practice can reduce this variability and thereby improve attention. And so this was a study where we tested participants who were going. This was a Theravadan retreat center that you've been to, Your Holiness, the Insight Meditation Center in Barre, Massachusetts. And we tested practitioners who were practicing in a 3-month retreat. And we tested them before and after the 3-month retreat. And if you look to the right, the practitioners are labeled in these columns on the right. The practitioners are on the left side of that figure that's circled. And the white bars are how they responded before the retreat. And the gray bars are how they responded after the retreat. And what's being displayed is their variability in attention. So improved performance here would be reduced variability, decreased variability. Novices who just practice for 1 week, they're the same when they start out with as the practitioners, and they show no change after 3 months, no change whatsoever. Then we also measured the brain. And I should point out that this is work that was directed by my colleague Antoine Lutz in our laboratory, and you've met Antoine on several occasions. He was actually one of Francisco Varela's last students. And after Francisco passed, he came to our lab. And what we show here is there's a specific measure of brain activity that's very, very interesting. And the best way for me to describe this measure is by using a metaphor. The measure is called phase locking. And it's phase locking between the external stimulus and what's going on in the brain. What the participants are doing is they're asked to pay attention to sounds, which are presented in headphones, and we have sounds that are going along, and every now and then there are tones, every now and then there's a tone of a different pitch. So it may be like this: boop, 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 beep. And the practitioners have to notice when the beep occurs, and it's going into each of the 2 ears, and they're instructed to press a button when the beep occurs only if it's in one ear and not the other. And when the beeps are going very, very quickly, it's actually a very demanding task. And what we can use this task to track what's going on in the brain. Now, this phase locking can be described in this way. If you have a lake which is very, very still, and you toss a stone into the lake, if you're on the other side of the lake, you would be able to see the ripples in this very still lake. If the lake is turbulent, if there's a lot of waves, if you toss the stone, you wouldn't be able to see because...
Yes.
So this is the same in the brain.
Beautiful metaphor.
Pardon?
Beautiful metaphor.
Oh, thank you. I learned my metaphors from Mathieu La, who is the master of metaphor. I take no credit. What we see in the brain is the same thing. And what we see in the brain is that over the course of 3 months, the practitioners show a stiller mind. And so they are able to show a synchrony between the occurrence of the beep and the measured response, particularly in the frontal part of the brain. And so this is the primary change that we're able to track. So there is much more to say. I've only gotten through about 25%, but we'll have much more time in the afternoon. I want to be sure to leave the same amount of time for my very dear colleague Tanya.
아주 밀 레벨 거리 시비셔야돼서 컴퓨터 레벨 떠스다 녀업샤.
So maybe the computer is rebelling because we've been extolling the virtues of human brain.
So 컴퓨터 브레인 녀어서.
So it's like the computer is bored, you know.
Huh? Did it? Oh, can you?
It disappeared onto a second and invisible screen. It turned out that it was hiding in another part of the universe. So now we're going to be hearing from our distinguished colleague Tanya Singer, who comes to us from Germany and the Max Planck Institute in Leipzig.
So what I wanted to do, His Holiness, is a great honor to talk again. I will present some things you heard in Delhi, but with more time, and we can go more in discussion, I hope. So what I want to do is to complement the view of Vichy, but coming to the question of whether we can train compassion and empathy. So I think one monastic scholar asked in the first day whether we can also find brain correlates to something precious like compassion. And I hope I will show you that we can find correlates. The question about how they relate is another question. The hard question of consciousness, as you said. And we will have another meeting tomorrow about the question how experience and neural correlates hang together. What I also want to do is to tell you a story about how the working together of monastic monks, in that case my favorite guinea pig, Mathieu Ricard, helped us to understand our models better. So how we kind of combine first-person perspective and experience with our methods and how we developed a new way of thinking through the cooperation. So let me introduce first a model we developed as the basis for a 1-year longitudinal mental training study. And we will start in 2 months, so I cannot give you any data from 1 year, but I will show you data of 1 week and several weeks. So, as Richie said, when we start doing mental training or plasticity research, we first have to define which cognitive processes we want to focus on. What do we want to cultivate and what do we want to train? And so cognitive psychology came up with a lot of different distinctions. So for example, here we will train the first 3 months attentional abilities, like Richie was just telling, like just coming back to the present moment, bringing the mind back from the past or future to the moment here. And we also train interoceptive awareness. And interoceptive awareness is getting aware of signals from the body. Hot, cold, heartbeat, so on. And I'm not talking today about that, but each of these processes have particular circuitry in the brain. Each process can be distinguished in the underlying circuitry which subserve them in the brain. Now, we have 2 other modules of 3 months everyday training, which we call affective and perspective, which is more cognitive in nature. So in the affective, we train something like loving kindness, increasing thankfulness, feeling of warmth and concern and compassion. But also we learn what Richie was saying. What do we do if we have anger and fear? You cannot go directly into compassion if you're full of stress and anger. So how do you solve this problem? And then in contrast to that, the perspective block is perhaps what in Buddhism is called view or wisdom. It's a bit like the 2 wings of compassion, I think. So it is more related to an understanding, a cognitive understanding, and what we call, for example, metacognition. So cognition would be memory, attention. Metacognition is to become aware of what your mind is doing. It's like 1 level above. And you also need this capacity to become aware of what you have for conception of self. Get aware of construction of self and how self operates. Okay, so now I want to show you why these distinctions. So that's a model now just to show how we think about studying plasticity. So what we usually do when we start such a training study is to measure, for example, also genetic information of the subjects and information about their upbringing, the mother, the parents, the children, because we want to see how differences in the genetic makeup, but also difference in how people have been raised, predict how they will learn and whether different types of people will learn different methods more easy or more difficult. And I can come to that later. And then we assume that mental training changes the brain. This is the concept of brain plasticity. And that these changes help predict changes in experience, subjective experience. So we measure subjective experience, but also on another level, health. So we measure stress hormones, heart rate, immune system, and so on. And then the last level is behavior. Do people act differently? And so, as Richie showed you yesterday, we have a lot of different tasks which are, designed to measure attention or prosocial behavior and so on. So that's the basic underlying model of this research. Okay, now, why do we separate these two? Why do we make this distinction? Partly because a field which is called social neuroscience and which wants to understand how do we understand other people? How do I know what you feel or what you think if I'm not in you? How do the brain solve this problem? And over many years, there has been more and more insight that there are different routes to the understanding of other people. So either I can feel what you feel, and this is what we would call an emotional or affective route. And this is, for example, empathy and compassion. belong to this affective root. They are phenomena which reside here. And then there is another way to understand other people through knowledge-based inference. So, for example, this would be, because I know that Buddhists have a view that consciousness exists also if the brain dies, you have different assumptions than Western scientists when they are materialists, and they think consciousness collapses when the brain dies. And this kind of inference is... That's an inference I do not because I can feel something, but because I know about Buddhist philosophy, and it's a cognitive inference. And you call that cognitive perspective taking. To some extent, I can go into your mind because I know about the world and about your thoughts and beliefs, but I don't feel, I'm not in an emotional resonance. And the empathy root, the definition of empathy, is that I can directly go into emotional affective resonance if you feel, for example, pain. I feel pain, like my own pain. So this is an affective resonance which is directly and feels like something, it's not cognitive. And then I will show you why it is very...
compassion shukchadwa.
Empathy net empathy. What you are suggesting, that because when you feel very strong compassion for someone, you actually have a much stronger empathetic connection with that person.
Okay. So we can discuss that, because we understood a lot about empathy, but not a lot about the construct of compassion. And we only through time and studying these phenomena. So in a way, the difference between empathy and compassion, and I will tell you how we got also to understand why it's very important to make a difference between these concepts, is that compassion is not necessarily only to feel the same thing than you feel. So if you are in pain, I'm in pain. If you enjoy, I'm in joy. This is empathy. We share the same state. But compassion is more, you can be in pain, but I can feel concern and a motivation to want to relieve your suffering without feeling the pain. This is possible. To have compassion, which is a warm feeling, is also an affective, motivational state, but doesn't have to share the pain. And when you look into the brain, and many studies have shown, if that empathy and compassion rely on different networks in the brain than this kind of more cognitive way of understanding the world. And the green pathways in the brain are showing the cognitive perspective taking, the understanding network. And they develop later in children. Whereas the pathways which have been referred to as emotion circuitry or limbic circuitry, which are orange, like the insula, they develop early. Children with 1.5 years have already empathy, very early, before their brain matures to be able to make cognitive inference. So we are connected in a way of affect earlier than we are connected in an understanding way to the other in childhood. Okay, so let me now focus on the research between empathy and compassion. Why do we do the difference? Why, is it important? So, when neuroscientists started to want to investigate such phenomena like empathy, they had the hypothesis that perhaps how can I feel when you have pain, even though I don't feel it in my body? I don't have pain, so how do I know how you feel? So the hypothesis was that observing your pain activates neural network in my brain, which usually process my own pain if I really get pain. And through this activation of networks, which are first-person pain network, I can now understand, this is how it feels. I feel it in my body and in my brain, basically. My brain codes for it. And we have a lot of evidence, which is called the shared network empathy hypothesis, that observing other people's emotions activates the same neuronal circuitry which process the very same emotion in myself. So now the problem with that is, if you suffer, then I suffer too. Is that helpful? Is that helpful for me being a good person, pro-social, helping the world? So even though in the West people always say it's good to have a lot of empathy and it's something we have to train, we were not so sure. And when we met Mathieu Ricard the first time, we asked him to come into our lab. And you see here, these are monks in the lab, and on the right side, Mathieu Ricard, which coming out of a brain scanner after 1 hour of torture from us. Because we had access to a modern technology which gives you, it's called real-time fMRI. So while he is in the scanner, we can see, and we ask him to go into different states of consciousness. Compassion, sometimes imagine afflictive emotion. He was not good in imagining afflictive emotion, better in compassion. But we can see the brain activity while he is in the scanner doing all these different states. So we asked him to go in different states. And first, we asked him, can you go into different compassion-related states? So what he did is different ways, what he calls, but he will tell you more what he did from the inside. It's non-referential compassion or loving kindness. And what was stunning is that I thought that he is now empathizing with the suffering of someone. But the brain signal which came out was totally different. It didn't look like the hundreds of studies we had made with untrained brain. So when he came out, I asked him, what are you doing? Are you not suffering, not feeling the pain? Because the network is so different. You are activating a network we know is involved in positive emotion, warmth, and affiliation. And so Mathieu explained from his first-person perspective what he was feeling, and that it was a very strong motivation and warmth and concern, but not necessarily pain. So we forced him to do empathy for pain. We said, you go back, and now please just go in empathy and suffering with the other, and don't go in compassion. Stop and just imagine suffering on your body. And here we saw the signal. We saw the pain-related network lighting up now. So at least we said, okay, Mathieu has a normal brain. When he imagines suffering and really goes in empathy, he can show that. And this helped us developing a model where we differentiated between the capacity of empathy and compassion. And so our model would state that we all have empathy. We are born with the capacity to resonate with the suffering of others. However, if it's too strong, it can turn into personal egocentric distress. You know, it can lead to very negative emotion and stress and to overwhelm. So this is the pathway down there. And why is this important? Because in helping profession, a lot of people make suicide. Doctors, nurses, a lot of people which have to deal with everyday suffering end their lives because they cannot cope. They don't know how to cope. And the suggestion is that if you know how to turn empathy, resonance, into compassion, then you are safe. Because you know how to develop positive emotions of concern. It's about the other, not about me. And you develop pro-social motivation, a strong motivation to help. So, you know, it's nice to have one brain like Mathieu, but science doesn't believe in one brain. So to test this model, we started to do different training study. And this is just a 1 week. It's very short, but it's a beginning. And we trained one control group in memory. It's a mental training technique to improve memory. And the other group in loving kindness and compassion. So probably I don't have to explain people here what loving kindness is. But given we had a secular training, we said to the students, it were students, university students, which had never done any practice, we said, start with imagining, for example, the picture of your mother, or a dear friend, or a loved one, or your children. And just try to improve this. And after and then we scanned their brain before and after, and they watched videos of news, small news pieces from BBC about suffering in the world. There is enough suffering in the world. So we had hundreds of news segments of dying people, starving people, women crying because they lost their children in accidents and so on. And we scanned the brain of the participants when they were watching this very, very negative, strong material. And we asked them how much negative emotion you felt, how much stress, negative emotion, and how much positive emotion. And non-trained people, at the beginning, all reported very negative emotions when they saw this video. And it was going along with activation in a network which was known to process negative affect, stress, alarm network. It's like very big. So now we...
when you use the word negative and positive, what the basis?
The demarcation, what's the definition?
The definition of...
And also is when you mentioned wholesome, right? Wholesome thoughts.
So I think there is a difference between Buddhist tradition and Western science, that we don't define emotions in terms of their function, whether they are adaptive, wholesome, or destructive, but according to the qualia.
Tanya, am I right in informing His Holiness the way in which modern psychological sciences distinguish between the two is when the actual emotion arises, how do you feel? If you feel good,
exactly,
then it's positive. If you feel
negative
and bad
yes,
and unhappy, it's more on that spectrum are negative. So it's really kind of a phenomenologically defined.
Yes.
Is that, am I right?
It's
And it's all
aversion. It's aversion, the feeling of aversion and liking.
Yeah, just to point out, I think this is going to be one of the most fruitful areas of dialogue between Western psychology and neuroscience and Buddhism, because I think that the wholesome-unwholesome distinction has not been tested in a serious way in Western science.
Yeah.
And I think that that is something that we can test. And it would lead to a very different organization of emotion, and I think it has many important implications.
And another...
Still, I believe, this is Kasoda, based on
It's a secular context.
So when we use the word Buddhism, then it's secular marta.
Right, so when you say Buddhism, then it has non-secular aspects.
But, yeah.
So that's why you see, I think at the beginning in Shemasanganda,
네,
Buddhist science,
Buddhist science lang.
she needs to share the secular.
So because if we bring that aspects from the classical Buddhist sources that really pertain to exploration and understanding of the actual nature of reality, then it will fit nicely within this secular framework. So earlier His Holiness was saying that this distinguishing between positive and negative based on affect is actually suits nicely within the secular context.
Yes.
Simply, it's some kind of feel happy,
Right.
feel comfortable. That's
Positive.
since we want that, we appreciate that, so we call positive.
Positive.
Something, although I think some people, I think when develop, you say anger, perhaps they get an anger and with some harsh word, I think the person may get some satisfaction. But this has a short term, right?
Right.
Long term, the consequences of anger very bad for their health. So therefore, consider negative.
Yeah. But I think
Not
one
talking about next life or not talking about nirvana or these things. So,
one of the crucial emotions, though, will be sadness, because sadness can sometimes play I think, beneficial role, and it may, in the moment, not be associated with happiness, but it may have some, I think, beneficial quality. But we can talk about this later. But anger is clear. Anger is clear.
sadness is the cancer study. I think according to Buddhism, Four Noble Truths, the first Noble Truth, you see because of some connection with sadness, right? But because there is alternative, third Noble Truth, and there is a way to achieve that fourth Noble Truth.
Yes.
Therefore, thinking reminds sadness is something fruitful. Otherwise, no use.
Exactly.
Okay.
And perhaps you could even now, in this model, say...
Here, I think, as you mentioned, is a big distinction. Empathy and because of compassion. Right? Sadness, so realize this is this sort of suffering. This is the cause of suffering. More deeper sort of thinking about that may not bring sadness. I think that more holistic. Now, for example, the Four Noble Truths. Once you see you have clear picture about third Noble Truth, and the proper way achieve that Four Noble Truths. Is it thinking more because of the suffering? You get more because of the will. Enthusiasm. And because of the deep down, there's some kind of tremendous courage, tremendous sort of
courage.
And I think some kind of very, very, very positive sort of mental sort of attitude, full of courage. So that I don't think sadness.
No sadness. Do you need to
Sadness
feel
doesn't
suffering?
because demoralized. That's sadness. Realize the suffering. And even you feel, but full of sort of determination, full of willpower, I don't think there is sadness. Oh, French expert, what do you say? What do you say? Do you agree? Oh, Italian. Yes, sir.
And do you think that you need empathy for suffering first before developing compassion?
So it's
not common.
a slightly complicated issue because in the Western conception of empathy, there seems to be a suggestion for the need for resonance. So, so it suggests that in order to have empathy, the person who is feeling compassion also needs to feel the other's pain.
Yes.
But perhaps I think someone, physical pain, passing through physical painful experience. You see, there's no possible way, impossible, you see, to get your own physical pain. No.
You can.
But mentally, yes, very painful sort of feeling.
So mentally you feel the pain of the other, but not physical.
Oh, 죄송한가? pain said the cancer should develop too.
So it's still
It's very.
it's a tricky.
It's
it's
very-
a difficult question.
It's very interesting. Perhaps I may add some neuroscience on pain. The pain, when we have a pain network,
너 많이 뭐 생년디
싫어.